Goldmann tonometry and other forms of tonometry. Goldmann tonometry is one of the accurate method to measure the intraocular pressure. So it works on Imbert-Fick principle, which states the pressure inside the sphere, for example cornea, it is equal to the force necessary to flatten its surface. So for example, this is the surface and this is how force is applied by Goldmann tonometer divided by the area of flattening, and this is the area of flattening. Usually the area is equal to 3.06 millimeter diameter contact surface of the Goldmann prism. This is Goldmann prism. First of all, it is disinfected by 2% sodium hypochlorite or 70% isopropyl alcohol wipes. Disposable tonometer prisms and caps are also available. Technique. So the actual technique you can learn in hospital, but the important points are: initially topical anesthetic is applied to the eye and then fluorescein drop. Then the patient is positioned at the slit lamp with the chin rest and forehead rest. Cobalt blue filter is used. So cobalt blue filter is on, and illumination of maximal intensity is directed obliquely. Usually it's 60 degree. So the illumination is 60 degree. The prism is centered in front of the apex of cornea, just like you can see in the picture. The prism is centered in front of the apex of cornea. The dial on the tonometer is preset at 1. 1 means 10 millimeter of mercury, and then you should increase it and advance it until it just touches the apex of the cornea. So by rotating, it will touch the cornea, and then the two green semicircular mires will appear. So these are two green semicircular mires which you can see on the slit lamp after the prism touches the cornea. So you should rotate the prism, you should rotate the dial until the inner margins of the semicircles align, just like shown in this picture. So if it is like this picture, you should increase the value, and in this, if initially it is this picture, you should decrease the value. So this will be the actual look of the semicircular mires when you are measuring the intraocular pressure. So when the 3.06 millimeter area is flattened, you will see this type of mires. So error can occur due to different reasons, which you should know. The first one is inappropriate fluorescein pattern. If there is excessive fluorescein or there is too thick fluorescein, then there will be error in the mires. So the mires will appear like the mires will be too thick, so it means there is excessive fluorescein. Pressure on the globe by the examiner fingers or eyelid squeezing by the patient or restricted extraocular muscles, it will give high reading. So the pressure on the globe will give high reading, so do not exert pressure on the eyelids. Central corneal thickness, it is very important. Normally 520 micrometer. So if it is thinner, it will give an underestimation of intraocular pressure. Thicker in ocular hypertension, the central corneal thickness is thicker, and the central corneal thickness is thinner in normal tension glaucoma and refractive surgery procedures. So thinner cornea, underestimation of IOP, Thicker cornea, overestimation of IOP. So dynamic contour tonometry, it is a new technology for non-invasive and direct IOP measurement, and it has been proposed to accurately measure the true IOP irrespective of the corneal thickness. It is based on the principle that when the tip of the device exactly matches the contour of the cornea, the pressure measured by a transducer placed on its tip is an accurate indicator of the true IOP. Electronic indentation or applanation tonometry, for example tonopin. This is tonopin. It involves both applanation and indentation process. It is a small handheld battery power portable device. The tonometer has an applanating foot plate with a tiny plunger protruding minimally from the center. As the tonometer makes contact with the eye, the plunger receives resistance from the cornea and the IOP producing a record of rising force by a strain gauge. At the moment of applanation, the force is shared by the foot plate and the plunger, resulting in a momentary small decrease from the steadily increasing force. So this is the point of applanation, which is recorded electronically. Multiple readings are taken and they are averaged. So the area applanation is known, the IOP can then be calculated, and it correlates well with goldmann tonometry within normal IOP range. Rebound tonometry. The newest version of the rebound tonometer is the iCare device. 1.8 mm diameter plastic ball on the stainless steel wire is held in place by an electromagnetic field in a handheld battery powered device. When a button is pushed, a spring drives the wire and ball forward rapidly. When the ball hits the cornea, the ball and wire decelerate. The deceleration is more rapid if the IOP is high and slower if the IOP is low. The speed of deceleration is measured and is converted by the device into IOP. No anesthetic is necessary. It shows good agreement with goldmann and tonopen reading. IOP measurements obtained with this tonometer have also shown to be influenced by central corneal thickness, with higher IOP reading with thicker corneas. It is also affected by other biochemical properties of the cornea, including corneal hysteresis and corneal resistance factor. Indentation impression tonometry. For example, Chiard's tonometer. The Chiard's tonometer, as you can see here, it consists of a curved foot plate. So it consists of a curved foot plate, which this is shown here, curved foot plate. It is placed on the cornea of a supine subject. A weighted plunger attached. This is a weighted plunger attached to the foot plate sink into the cornea in an amount that is indirectly proportional to the pressure in the eye. So this plunger will sink into the cornea of a soft eye further than it will into a harder eye. A scale at the top of the plunger gives a reading depending on how much the plunger sinks into the cornea. So this is the scale. This scale at the top of the plunger gives reading depending on how much the plunger sinks into the cornea, and a conversion table converts the scale reading into IOP measuring in millimeter of mercury.